तो हेलो गाइस, तो वेलकम बैक टू अनदर लाइव सेशन विद अभय। एंड आज के इस वीडियो में हम लोग बात करने वाले हैं वही मैट्रिक्स चेन मल्टीप्लिकेशन जिसकी हमने कल बात करी थी, पर वो बात पूरी हो नहीं पाई थी क्योंकि उसमें कई सारी चीज़ें ऐसी थी जो समझ में नहीं आई थी। बाद में मुझे पता चला कि अब्दुल बारी सर ने खुद उसके ऊपर एक दूसरी वीडियो बना रखी है, मात्र इसलिए क्योंकि उन्होंने बहुत सारी चीज़ें मिस कर दी थी अपनी पहली वीडियो में। तो विदाउट वेस्टिंग एनी फर्दर टाइम, लेट्स स्टार्ट।
Hi, topic of this video is matrix chain multiplication. Already I have one video in my playlist, but there are few things I have missed there in that video, so it may be a little bit confusing for the students, so I'm making a new video on the same topic. The problem in YouTube is we cannot edit the video, I cannot add something to the video, so I have to make a new video once again. So the contents of the video are: what is matrix multiplication? I'll explain this. Then what does it mean by matrix chain multiplication, and how to apply dynamic programming. So here I'll be giving you the idea, approach for solving a problem using dynamic programming, right? Then if you are interested in learning problem solving, then don't miss this part. Then I'll use the formula of dynamic programming and show you how to solve the problem, what should be the approach for solving the problem. Then the last thing, I'll show you an example problem. And if you're here one day before the examination, then you need this.
मुझे लग रहा है यार इसमें ना, मतलब लाइक ये कुछ ज्यादा ही हो गया है, इसको थोड़ा आवाज को कम कर लेते हैं। और मुझे पता नहीं है यार कि मैंने ये खोल रखा था क्या बोलते हैं, ऑडियो ऑन कर रखी थी कि नहीं। तो दोबारा से बोल देते हैं कि कल हम लोग पढ़ रहे थे मैट्रिक्स चेन मल्टीप्लिकेशन के बारे में यूजिंग डायनेमिक प्रोग्रामिंग, और वो तुम्हारा सही से हो नहीं पाया था क्योंकि उसमें कुछ कुछ चीजें सर ने ड्रॉप कर दी थी। तो उसी लिए सर ने दोबारा से एक अपना लाइक वीडियो रिलीज किया था, तो वही वीडियो आज हम लोग देखने वाले हैं।
This one directly, so you can directly jump onto this part of the video and you can finish it. So you learn how to solve a problem, that's all, right? So how the formula is obtained and all details, you have to spend time definitely. And if you're watching for learning the problem and learning problem solving, then there are a lot of things to learn from this video. So let us start with matrix multiplication. First video. So let us start with matrix multiplication. First of all, matrix multiplication. See, there are two matrices in this example, A and B. A is of dimension 2 rows, 3 columns, 2 rows and 3 columns, and B is of dimension 3 rows and 2 columns, 3 rows and 2 columns. First of all, the condition for multiplying two matrices is the number of columns of the first matrix must be equal to number of rows of second matrix. Means these two must be equal. That is, these two must be equal. Then multiplication can be done. This is the condition for multiplication. And how we multiply is, we multiply all the elements of a row, single row, with all the elements of a single
Single
column.
column.
Multiply the elements and add their products. So that is shown here. This is how multiplication is done. So this is how one single element is obtained. But what is the dimension of the resultant matrix? The resultant matrix A into B, let us call it as C. This is of dimension 2 cross 2.
Okay.
Then one more thing. Total how many multiplications I have done? Let us see. 1, 2, 3. 1, 2, 3. So 3 how many times? 4 times. So 12 multiplications I have done. So actually if you see the number of multiplications I have done for getting this result is 2, 3, 2. 2 2 is 4, 4 3 is 12. 12 multiplications I have done for obtaining this resultant matrix, that is A into B. So from this we have to pick a few things. First is, when two matrices can be multiplied, this condition that this must be equal, then only multiplication can be done. This is the important thing. Second thing, what will be the resultant matrix, dimension of the resultant matrix? The dimension of the resultant matrix will be these two extremes, that is number of rows of first matrix and the number of columns of second matrix, that is 2 cross 2. This is the second point. And the third point that we have to pick up is, for generating or multiplying the matrix, total how many multiplications are required? That is this dimension into this one and this one. This is common, right? This is same. So 2 into 3 into 2.
Okay.
So 2 into 3 into 2. These many multiplications are required. So these are the important things. And one more important thing I will show you that we must know for further understanding. See, I have two matrices A and B. And if you take dimensions, total how many are there? First, second, third, fourth. So
Four
this
dimensions.
is total 4 dimensions.
4 dimensions.
But these two must be same. So let us call it as 1.
1.
So if we call it as 1, then total how many dimensions?
Total dimensions.
2, 3. So total 3 dimensions are there. 3 different values are there, right? And this is the first matrix dimension, and these are the second matrix dimension.
Distinct
And one of the dimension is common. So for the two matrices, total 3 different dimensions are there, where one of the dimension is common for them. So that's all the important things I have highlighted here that is useful for matrix chain multiplication. Now let us learn about what does it mean by matrix chain multiplication. For explaining matrix chain multiplication, I have an example here. I have 3 matrices A1, A2, A3, and I want to multiply them. So there are more than 2 matrices. So, and I want to multiply them. So first of all, check whether they can be multiplied or not. See, if I take these 2 matrices, then the dimensions, this should be matching. Number of columns of first one should be equal to number of rows of second one. Yes, they are matching. They can be multiplied. And if I take these 2 and
These 2 also can be multiplied.
They can be multiplied. Now these are A1, A2, A3. Dimensions also I will label them. Let us call this as a D0. And these 2 are same, so let us call both of them as D1, D1. And these 2 are same, so this let us call this as D2, D2, and D3. This labeling may help us afterwards. I have given the labels. Now let us proceed. So I want to multiply these 3 matrices. Now the question is, can I multiply all 3 together? No, I have to multiply 2 matrices.
2 multiplications at a time.
Then what are the
2
possibilities?
matrices at
See,
a
the
time.
first method is, I can multiply A1 with A2 and the result with A3. This is one possible. And another possible method is A1 as it is. Then A2 and A3 I should multiply first. Then the A1 should be multiplied with the result of product of A2 and A3. So there are 2 possible methods. See, whether this one and this one gives same result? Yes, they are associative. Associative property holds on matrix multiplication. Whether you multiply these 2 first, then the result with this one, or first these 2 and this with the result, you get the same answer. So the product of 3 matrices will be same. So you can multiply it in either way. Now, whatever the elements may be there in A1, A2, A3, I am not interested in that. I am not really trying to multiply them. I want to know how much efforts I have to put in for multiplying them.
Let me check
So let us
whether
see.
the
If
like.
I multiply,
Let me first check whether we are looking good on the on the audio side. Let me check it first. I think the music audio may be a bit too loud. Let me check it. So where am I? Yeah, this is live, like on the audio.
what does it mean by matrix chain multiplication? For explaining matrix chain multiplication, I have an example here. These three matrices. Now the question is, can I multiply all? Then A2.
So the noise
Whether
is
you multiply
like
these two first,
they
then the result with this one, or
check whether the
if I multiply.
let me first check whether okay, got it. So I am using noise suppression, that's why noise suppression, that's why it might be first. I think like the music audio may be a bit too loud. Got it. I'm using audio compressor, not compressor exactly, what's the suppression, noise suppression I am using. So that's why it might be cutting up that particular like that music in the background. I was playing music in the background, but it was abruptly like cutting or abruptly abruptly occurring when I speak. So that's why I stopped the music. Let's come back to our problem and see it.
By A1 with A2, then total how many multiplications I have to do, how many multiplications I have to perform. So what are those dimensions? 2, 3 and 3, 4. So total how many multiplications will be done here for multiplying this? This is 2 into 3 into 4. These are 24 multiplications. This side, total 24 multiplications. If I'm multiplying matrices A1 with A2, total 24 multiplications I have to perform for those elements. Now what about this one? This is dimensions are 4, 2, but how many this, if you take this separately, no multiplications required for this one. So 24 multiplications for this, and this is nothing. Now I have to multiply these two together, right? This whole thing with this one. So total how many multiplications required for this? This will be having dimensions 2 cross 4, right? So you remember the resultant matrix will have the dimensions of these two, number of rows of first one and number of columns of second one, these two, and this one 4, 2. So these two are same. Yes, multiplication can be done. So total how many multiplications for this? This is 2 into 4 into 2. So these are 16 multiplications, right? These are total 16. Now if you find out altogether 24 multiplications this side plus 0 multiplications that side plus a 16 multiplication. So this is how much? 24 plus 16, 40 multiplications I have to do. Multiplying these two takes 24 multiplications, and this is nothing. This is a single matrix 0. Then multiplying these two together is 2, 4, 2. So total 40 multiplications are required. What about this? Let us take this. The dimensions are 2, 3, and this is 3, 4, and 4, 2. First of all, I have to multiply this. This is 3 into 4 into 2. So this is 24. And the result of this is the dimensions will be 3, 2. And what about this side? This side will be 0. No multiplications required on this side. Now when I have to multiply these two together, the dimensions are 2, 3, and this is 3, 2, right? These are the dimensions, like this one and this one. So these two are common, so same, we can multiply. These two are same, we can multiply. So total how many multiplications required for this one? 2 into 3 into 2. Then plus, what about this side? 0. What about this side? This is total multiplications are 24. So 24 plus this is 2, 3, 6, 12. So this is 36 multiplication. So total 36 multiplications are required. So observe this carefully. You watch it once again. This portion is very important, this calculation. And from this we can say that if I multiply these two first and the result with this one, or this with the result of this one, the cost of multiplication is different. Mean the number of multiplications I have to perform for getting the results are different. So which parenthesization is better? Means first I should multiply these two matrices, then this with the result of this one. That will take only 36 multiplication. So it's a small example of just 3 matrices, and there's a difference of just 4. So 4 is not a small figure, right? Because the number of matrices are very small. We are looking at a very small level. If suppose you have matrices A1 multiplied with A2 multiplied with A3 goes on to A10. There. total cost of multiplication means which matrices should be multiplied first. It is a big problem there. So you cannot simply start multiplying A1 with A2, then the result with A3, the result with A4. So it will be very, very huge. If you find out an easier method for multiplying them, then it's better. So first find out how to multiply them, then multiply the matrices. So that's it. If you have the chain of matrices for multiplication, then first of all find out which multiplication should be performed such that the total efforts put in for multiplying them should be minimized. This is matrix chain multiplication problem. So if the chain of matrices are there, that has to be multiplied, how the parenthesization should be done such that the efforts required for multiplying the matrices should be less. See, here you can see that if you multiply these two and the result with this one is 40 and this way it is 36, so this is better. And if you have 10 matrices, then there may be a different possibilities and one of the possibility may be a best possibility. So that's it. We have to find out the best possible parenthesis.
तो हम लोग बेसिकली इसमें क्या कर रहे हैं, इसमें हम लोग देख रहे हैं अगर हम लोग एक से ज़्यादा लाइक दो से ज़्यादा एक से ज़्यादा होगा ना, हम लोग दो से ज़्यादा मैट्रिसेस को अगर मल्टीप्लाई कर रहे हैं तो हम उनका ऑर्डर देख रहे हैं, लाइक कौन सी दो मैट्रिसेस पहले चूज़ करी जाएँ, उनका मल्टीप्लाई करके और फिर जो आंसर आएगा उसका मल्टीप्लाई अगली बची हुई से करेंगे। तो इससे हम लोगों का कॉस्ट जो है वो डिफरेंट आ रहा है, जैसा इस दोनों के केस में देख रहे हो। यहाँ पे A1 क्रॉस A2 पहले किया गया, यहाँ पे A2 लाइक यहाँ पे A1 क्रॉस A2 पहले किया गया, यहाँ पे A2 क्रॉस A3 पहले किया गया। A1 क्रॉस A2 करने के लिए यहाँ पे जो A1 थी वो 2/3 की मैट्रिक्स थी और A2 थी वो 3/4 की मैट्रिक्स थी, A3 थी 4/2 की मैट्रिक्स थी। तो A1 क्रॉस A2 करेंगे तो हम लोगों का जो टोटल मल्टीप्लिकेशन आएंगे, नंबर ऑफ मल्टीप्लिकेशन आएंगे वो आएंगे 24। और जो A3 है ये यहाँ पे मानते हैं अकेला है तो इसका तो कहीं मल्टीप्लाई अभी करना नहीं है, तो इसका 0 आ गया इस वाले स्टेप में। पहले लेवल पे इसका 24 आया, इसका 0 आया। अब क्या करेंगे हम लोग करेंगे इन दोनों का, ठीक है। तो ये जो मेरी मैट्रिक्स आएगी यहाँ पे आएगी 2/4, 2 यहाँ से आएगा 4 यहाँ से आएगा और ये दोनों कॉमन है तो नहीं आएगा। तो 2/4 जो मैट्रिक्स आएगी वो अगली वाली जो यहाँ पे मैट्रिक्स थी वो 4/2 थी, तो इससे मल्टीप्लाई करेंगे तो यहाँ पे कितने नंबर ऑफ मल्टीप्लिकेशन चाहिए होंगे, 16 मल्टीप्लिकेशन चाहिए होंगे। तो इस वाले स्टेप में 16 मल्टीप्लिकेशन टोटल लगेंगे और ऊपर वाले स्टेप में टोटल लगेंगे 24 + 0। तो टोटल मिला के जो तुम्हारा मल्टीप्लिकेशन लगेगा वो 40 लगेगा, ठीक है यहाँ पे। और इस केस में सेम देखो 2 3 पहले 3 4 4 2 है तो यहाँ पे करेंगे तो कितना 24 हो जाएगा और फिर 2 3 का ऐसे ही 0 रहेगा। फिर नेक्स्ट में आएंगे तो यहाँ पे 2 3 है, यहाँ पे कितना हो जाएगा 3 2 हो जाएगा। तो 2 3 3 2 का करेंगे तो कितना आएगा 12 आएगा, ठीक है। देख लो करके 2 3 3 2, ठीक है। तो 12 आ गया। तो 12 और 24 ऐड करेंगे, 12 24 और 0 ऐड करेंगे तो 36 तुम्हारा आंसर आएगा। टोटल एफर्ट्स इस केस में टोटल एफर्ट्स यानी कि टोटल नंबर ऑफ मल्टीप्लिकेशंस इस केस में तुम्हारे 36 हैं तो इसी को हम टोटल कॉस्ट भी बोलते हैं। और इसमें 40 है तो इसको हम लोग इसका टोटल कॉस्ट बोलेंगे।
Such that the total cost of multiplication is minimized. Now we need an approach for finding the minimum one. So dynamic programming approach says that you should try all possible parenthesization and pick up the best one. All possible one and pick up the best one. So for 10 we have to try all possibilities and then whichever is giving minimum you have to take that pattern of multiplication. So for 3, how many are there? Only 2 are there. So we tried both of them and we found this is better. So we have already done this, but this we can't think of doing on 10 matrices. Imagine how many possibilities you will have. But we must find out all possible methods. From that we should pick up the best one. So for this we need some formula. That is, by using this approach we need some formula. Let us frame a formula for dynamic programming for matrix chain multiplication. So here already I have an example. So this I will convert it into a formula, right? I have 2 examples here. From this only I will make a formula. First of all, watch this very carefully. I am creating or generating a formula from this example. So let us say I want to find out the minimum cost for multiplication. So I have to find out the cost of 1 2 3. So there are 3 matrices. So let us say cost of 1 2 3. So I'll just write C now for cost. Okay, then let us look at this. Observe this. What is this? 24. This is the cost of multiplying 1 and 2. So I'll remove this, and this I will say cost of multiplying 1 to 2. And what is the 0? See, I was writing 0, that was not required that time, I should have skipped, but now this is useful. You see, this is cost of multiplying third matrix with the third matrix only. So the cost of this side is 1 to 2, cost of that side is 3 to 3, and that was 0, and this was 24. This was 24. I will write it, right? This is 0, 24 and 0. So cost of this one and cost of this one. So final result what I was getting, this was cost of 1 to 2 and this was cost of 3 to 3, and 3 to 3 is a 0 because it's a single matrix. Then what was this? The cost of multiplying these two together. So these are the dimensions I have. What is this dimension? This one. This is D0. This is D0. What is this dimension? This one. This is what? D2. This is D2. So this is D2. And what is this dimension? This one. Last one, right? What is that? D3. This is D3. So what are these? This is D0 and this is D2 and this is D3. D0, D2, D3. I have multiplied these 3 and I got the result as 40. Now let us convert this also into the formula. This is what? Cost of 1, 1. Cost of multiplying 1, 1 itself, that's 0. It's a single matrix only. And what is this? Cost of 2 to 3. And what is this? 24. How to get this one? This is 3 into 4 into 2. We know it well. So, and it is cost of multiplying 2 with 3. Then what is this? Cost of 1 comma 1. And this is what? Cost of 2 comma 3. And what are these dimensions? This is the first one, and that is D0. This is D0, right? And this is 3. This is a D1. 3 is a D1. Yes, this is D1. And this is the last one, that is D3. This is D3. And this is 36. So I have made it like a
अगर तुम ध्यान से देखोगे तो इधर आ रहा है तुम्हारा बाकी जो दो टर्म है, इसमें 1 to 2 है लेफ्ट वाले में, और कॉस्ट ऑफ 1 to 2 1 मल्टीप्लाई 2, और कॉस्ट ऑफ 3 to 3 प्लस D0 D2 D3 है। और इसमें क्या है? कॉस्ट ऑफ 1 to 1 है, 2 to 3 है, यानी कि हाँ क्या बोल सकते हैं इसमें, क्या सोच सकते हैं, जो तुम्हारा लास्ट एलिमेंट है, यानी जो एलिमेंट अकेला है, जो एलिमेंट तुम्हारा अकेला है उसका एक आ रहा है, तो आ ही रहा है, ठीक है। D1 नहीं आ रहा ना, पहले में D1 है ही नहीं, दूसरे में D1 है। ऐसा क्यों? क्योंकि इसमें 1 D1, अच्छा D0 है ना, इसमें D0 है, D1 तो गायब ही हो जाएगा, D1 गायब हो जाएगा, D2 बचेगा लास्ट में, D2 D3 बचेगा। अच्छा, तो D0 यानी कि जहाँ पे मल्टीप्लाई हो रही होगी, ठीक है, या जहाँ पे पैरेंथेसिस होगा वहाँ का डायमेंशन बचेगा। तो उस केस में देखो D2 बच रहा है, और इस केस में पैरेंथेसिस है तुम्हारा 1 पे, तो इसमें D1 बच रहा है, D2 नहीं बच रहा है क्योंकि 2 के अंदर कोई पैरेंथेसिस है नहीं। ठीक है, समझ गया।
formula. Cost of this side, left side, cost of right side, then cost of multiplying 2 together. So I got it in the form of formula. Let us observe this. If you observe 1, 2, 3, 3, 1, 1, 2, 3. So if you observe the first one and the last one are same, let us call this as I and this as J, and this as I and this as J. In both, I and J are same. Then what about this? D0, D3. D0, D3. And this is D1 and this is D2. So let us call this as D, I minus 1, and this is J is 3, right? This is DJ. Let us call this as D of I minus 1, and this is DJ. Then what is this? This is 2 and 3. This is 1 and 2. So if this is 1, this is 2. If this is 2, this is 3. This is what I am observing, right? This is my, from the observation I am creating a formula. Then this is a D1 and this is D2. So it means that part should come first. So let me write a formula. So I'll write the formula here. I'll write it here. See, I have to find out the cost of I comma J is what? This side. Cost of I comma, what is this? I should call it as K, and this is K plus 1. So, and here also I should call it as K, and this is K plus 1. So now if you observe, everything is perfect. See, C of IK, K plus 1 to J. C of IK, K plus 1 to J. So when you say IJ, that are 1, 3, and these are also.
नहीं सर, परफेक्ट कहाँ है? इसमें K plus 1 की वैल्यू आप 3 बोल रहे हो, इसमें K plus 1 की वैल्यू 2 हो जाएगी। अच्छा, उसमें लेकिन K भी तो वो है 1 है, ठीक है।
K is here 2 and 3, K is here 1 and 2, and this is 0 and 3, this is 0 and 3. So I minus 1J, I minus 1J, and this is DK. K is 1 first time and K is 2 second time. So let's call
K, ओके, तो इसको तुम बोल सकते हो D of I comma K, ये तुम्हारा C of I comma J जो होगा बराबर होगा मिनिमम ऑफ I comma K प्लस C of तुम्हारा J comma J हो जाएगा, ठीक है, प्लस D of I हो जाएगा, I minus 1 होगा ना,
as DK.
I minus 1 होगा,
So based on this I will write a formula. Now this side,
D of
C of IK, cost of left side, plus cost of right side, K plus 1 to J, then plus D of I minus 1, K and DJ. Dimension I minus 1 into, I'll remove this, dimension K into dimension J. So I have combined these two together in terms of IJK. Then what K is taking the value? K is here first time 1 and second time 2. So that should come first, then this one. So K can take the values that are starting from I is what? 1. So K takes the values from I but less than J. K is not becoming 3. K became 1 and K became 2. That's all. Out of these two, I want minimum. So this is the formula for.
ओके, समेशन कहाँ है सर? समेशन भी तो लगाना चाहिए आपको। तो तुम्हारा जो फॉर्मूला बना है वो कुल मिला के क्या बना है? तुम अगर ध्यान से देखो, तुम अपनी बुद्धि लगाओ, तिवारी जी बुद्धि लगाइए अपनी। हाँ, तो बुद्धि लगा रहे हैं कि हम लोग क्या निकाल रहे थे, हम लोग निकाल रहे थे 1,2, नहीं हम लोग निकाल रहे थे 1,3। तो हमारे लिए आई हो जाएगा, इसको हम मान लेते हैं, जे हम इसको मान लेते हैं। तो हम पहले कलर चेंज कर लेते हैं, कलर थोड़ा सा बदल लेते हैं। आई हम इसको मान लेते हैं, जे हम इसको मान लेते हैं, ठीक है। तो अगर हम सी ऑफ आई कॉमा जे की बात करें, ठीक है, तो वो हमारा हो जाएगा, क्या हो जाएगा, पहले तो हम लोग मिनिमम निकालेंगे। मिनिमम किसका निकालना है, हम लोग मिनिमम निकालना है सी ऑफ आई कॉमा के प्लस सी ऑफ जे कॉमा जे, जे कॉमा जे ही होना चाहिए वैसे तो, नहीं जे कॉमा जे नहीं होना चाहिए, क्या के प्लस वन कॉमा जे होगा ना, के प्लस वन कॉमा जे and then plus d of I minus 1 d of k multiply में होगा d of k and that one would be d of j, ठीक है। और जो k की वैल्यू है वो तुम्हारी रहेगी I बराबर k, लाइक k की वैल्यू I से स्टार्ट होकर j तक जाएगी, लेकिन j नहीं होगी, j से लेस देन ही रहेगी हमेशा, ठीक है। तो उस केस में अगर I को मैं 2 मानूं, ठीक है, और J को मैं 5 मान लूं, तो उस केस में जो तुम्हारा वो होगा, क्या बोलते हैं, उस केस में जो तुम्हारा उस केस में जो तुम्हारा फॉर्मूला होगा उसमें बहुत सारे टर्म आएंगे। पहला टर्म आएगा, आई को मैंने 2 माना है तो पहला जो टर्म आएगा सी ऑफ 2 कॉमा के की वैल्यू पहले 2 ही होगी, तो 2,2 प्लस सी ऑफ ये 2 का 3 हो जाएगा, 3,5 प्लस d1 जो हो जाएगा वो तुम्हारा कितना हो जाएगा, तो फिर मैं 3,5 की निकालूंगा, 3,5 की मैं वैसे ही निकालूंगा। मुझे बेसिकली 1,1 की लाइक मुझे आई की पता है वैल्यू, ठीक है, समझ गया।
Matrix chain multiplication. So from examples of just 3 matrices, I have prepared the formula. So the idea here is that, once again I will tell you, this is the cost of multiplying these two sides. Then what is the cost of left side, cost of right side? Those two are written here, cost of left side and cost of right side. How I multiply these? By multiplying 3 dimensions, right? What about this cost? This also multiply these dimensions, 3 dimensions, and get the result. Multiply these 3 dimensions and get the result. It's the same thing. So the cost of multiplying 2 matrices, you have to multiply the dimensions, and you get the number of multiplications. So here is the formula. This formula will give you minimum. So you should try different values of k. Here we tried k as 1, then k as 2. As you have 3 matrices, so only k value can be 1 and 2. If you have more matrices, then k value can be 1, 2, 3, 4, so on. If you have 10 matrices, up to 9 it will go. So this formula says that try all possibilities and pick up the best one, minimum one. What are the possibilities? You change the k value. So some on this side, some on that side. So now I will write on the formula here, and I will remove this, and I will show you how it looks like for 4 matrices. Then afterwards we will solve a problem. Here I have 4 matrices, and let us say dimensions are d0, d1 and d2, d3, d4. These are the dimensions. What are the possible ways of multiplying those matrices? Before actually multiplying matrices, we want to know which parenthesization will require less efforts of multiplication. So there are many methods of parenthesization. This is the first one, a1 with this one, a2 with the result of 2, 3, right, 3, 4. Then a1, then inside this 3, first I can multiply this 2, then this one. So this is another parenthesization. Or a1, a2 with result of a3, a4. Or this side, a4 is left over, a1 with result of a2, a3, then this entire thing with a4. Or first a1, a2, result with a3, result with a4. There are 5 different methods of parenthesization. So if you want to know for 4 matrices how many parenthesizations are possible, 5. So if you want to know how many multiplications required for this one, so there is a formula called Catalan number. As we have 4 matrices, so you can use that. Actually the formula is a 2n cn by n plus 1. But here you have to take n as number of matrices minus 1. So n should be 4 minus 1. You should not take n as a 4. Just you take 3 and then you get the answer. So if there are 4 matrices, then actual value if I write here is 2 into n minus 1 c of n minus 1 by n minus 1 plus 1 is n only. So this will be the formula modified for matrix chain multiplication. So let us
इसको क्या बोला, कैटलन फॉर्मूला बोला।
5 different methods of parenthesization. So if you want to know for 4 matrices how many parenthesizations are possible, 5. So if you want to know how many multiplications required for this one, so there is a formula called Catalan number. As we have 4 matrices, so you can use that. Actually the formula is a 2n cn by n plus 1. But here you have to take n as number of matrices minus 1. So n should be 4 minus 1.
What is Catalan number? Catalan numbers are a sequence of natural numbers that occur in various counting problems, often recursively defined objects. They are named after Eugene Catalan. Though they were previously discovered in 1730s by Mingetto, the nth Catalan number can be expressed directly in terms of the central binomial coefficients. That is this one. So basically NCN ही है ना, हाँ इसको 2NCN पढ़ेंगे, 2NCN पढ़ेंगे, ठीक है। तो 2NCN को डिवाइडेड बाय n प्लस 1, 2NCN डिवाइडेड बाय n प्लस 1। सही है भाई, सही है भाई। The first Catalan numbers for n0 for n is n0 0 1 2 3 are equal to 0 1 2 3 are 1 1 2 5 14 42 132 429 14 30 4860. An alternative expression for Cn, okay, which is equivalent to the expression, ठीक है। तो ये हो गया तुम्हारा एप्लीकेशन इन कॉम्बिनेट्रिक्स। देयर आर मेनी काउंटिंग प्रॉब्लम्स इन कॉम्बिनेट्रिक्स whose solution is given by Catalan numbers. The book Innovative Combinatorics Volume 2 by Combinatorics Richard P. Stanley contains a set of exercises which describe 66 different interpretations of the Catalan numbers. भाई Catalan numbers ऐसा ही खतरनाक। अच्छा, third proof, this bijective proof provides a natural explanation for n plus 1 appearing in denomination of formula। इतना Catalan नंबर तो कुछ खतरनाक सा लग रहा है। नंबर थ्योरी ना, नंबर थ्योरी नेक्स्ट लेवल
This one you should not take n as a 4, just you take 3 and then you get the answer. So if there are 4 matrices, then actual value if I write here is 2 into n minus 1 c of n minus 1 by n minus 1 plus 1 is n only. So this will be the formula modified for matrix chain multiplication. So let us put this one, I have 4 matrices, so this will be what? If I take 4 matrices, 2 into 4 minus 1, that is a 3, and c, this is also 3 by, this is n, 4 matrices are there, where n is 4, I have taken n as 4. So this will be 6c3 by 4. So 6c3 by 4 is 6 into 5 into 4 divided by 3 into 2 into 1 whole divided by 4, 4 gets cancelled, 2 3 6 cancel, so 5 is the answer. And if you take n is equals to 5 matrices, then take 1 less for n and put this in this formula, then you will get 14. So for 5 matrices, 14 multiplications are required, right? 14 possible parenthesizations are there. For this, 5 possible parenthesizations are there. So out of these 5, we have to pick up the best parenthesization that is giving minimum result. So this we will do it using the formula. So now I will remove this. I will use this formula and show you how I can apply that formula on these 4 matrices. And if I apply what problems I face, then I will show you the solution for that problem. Then later on we will solve a example problem. So I will use the formula on this 4 matrices. We don't have the dimensions, let them be D0, D1, D2 only. When we see the example, that time I'll take some values. If I apply the formula, the cost of C of 1 to 4, because 4 matrices are there that are 1 to 4. So I is 1 and J is 4. This should be minimum of K should take the values greater than or equal to I is what 1 and less than J, that is 4. So what are the possible values K can take? K can be 1, K can be 2, and K can be 3. 3 values are possible for K less than 4. So if I put K as 1 in this one, right, what it looks like? C of I is 1, J is 4. Remember this. 1 comma K is what? 1. Plus C of K plus 1. K is 1 means K is 2, K plus 1 is 2. And J is 4. Plus this is D of I minus 1. I is what? I is what? 1.
0.
This is 0. D0 plus K. DK. K is what now?
1.
K I am taking it as 1. K is 1 and this is into, and this is into D4.
D4.
This is K value as 1. If I take K value as a 2, this is 1 to 2 plus C of 3 to 4 plus D0 plus a D2, into D2 into D4. Then if I take K value as a 3, then this is 1 3 plus C of 4 4 plus D0 into D3 into D4. If I expand the formula, I get 3 different terms, 3 different values. Out of this, I have to take minimum. I'm not writing them in a single line. It will be very lengthy on paper, and you can do that, right? So comma, this, this one. So K is 1, K is 2, K is 3. Out of this, it is trying all possible parenthesization, right? So actually these means, if I draw, first one means A1 with A2, A3, A4. How they are multiplied, we don't know. So this is A1, 1, this is 2 to 4, the cost of this. And what is the cost of multiplying these two? Their dimensions, D0, D1 and D4. Then what the second one means? Second one means A1 with A2 and this parenthesis, then this is A3 and A4. So the parenthesization is done at matrix 2. K is a 2. So 1 to 2 on this side, 3 to 4 on this side, then cost of this and cost of this, then cost of multiplying these two, Then this one, last one says A1, A2, A3 and this side is A4. So the cost of multiplying all 3 with this result, 1 to 3 and 4 to 4, 1 to 3 and 4 to 4, then the cost of multiplying these two together. So So this is trying all possibilities. Now, if I know the answer, if I know the values, I can put these values and get the answer. So from this, you already know two values. So this is A11, this is 2 to 4, the cost of this. And what is the cost of multiplying these two? Their dimensions, D0, D1 and D4. Then what the second one means? Second one means A1 with A2 and this parenthesis, then this is A3 and A4. So the parenthesization is done at matrix 2. K is a 2. So 1 to 2 on this side, 3 to 4 on this side, then cost of this and cost of this, and then cost of multiplying these two, cost of multiplying these two. Then this one, last one says A1, A2, A3 and this side is A4. So the cost of multiplying all three with this result 1 to 3 and 4 to 4, 1 to 3 and 4 to 4, then the cost of multiplying these two together. So this is trying all possibilities. Now, if I know the answer, if I know the values, I can put these values and get the answer. So from this, you already know two values. What are those? C11, single matrix, 0. You remember, we have taken it. And C44, it's a 0. This is 0. Then what about C24? Let me put it here. This I can take it as 0, but C24, let me expand. C24 is minimum of, it's a formula again. K takes the values from 2
to 4.
So K can take what values? K can be 2.
K can be 2 and 3.
So 2 values it can take. Now from this, if I take the formula, see I is a 2, J is a 4. I is a 2, J is 4. Remember this. 2, 2,
2, plus 3, 4 plus dimension 2.
Sorry, this is
dimension 1 into dimension 2, dimension 4.
See, ik, k plus 1 to j, k is 1, right? This is di minus 1, dk and dj. So you can check it, you can pause and check it. I have used the formula here where k values 2, I, j and r to 4. Now c I k, k is 3, plus c of k plus 1, that is 4, to j, that is 4, then plus di minus 1, I is a 2, so d1 into dk, k is a 3, 3 into d4. Oh, it means that for finding c of 2, 4, again I need formulas. 2, 4, I need again formula. So in this one, this value I know, 0, 4, 4, 0. Then what about the 3, 4? So again I will find out. See, this entire formula is just one cost here, this one. What about this, what about this, what about this? I have to find out all of them. So it's too lengthy. For finding this one, first of all, I should find out this, right? And find out these. So why can't we first find out these smaller values, then go for larger value? So what does it mean by smaller value, larger value? Let us check this. 4 minus 1. How much? 3. So this requires 3 formulas, 3 values, right? 3 different values. This is 4 minus 2. This is 2. So this requires 2 values, out of which we will pick up any one. Then what about 3, 1, 2? It will have only one value. Only one value. What about 3, 4? It will have only one value. See, the difference is 1. Difference is 1. And difference is 0. Difference is 2. Right? Difference is 2. So it means first I should find out which formulas where the difference of I and j is 0. Then it is 1. Then it is a 2. Then it is a 3. In this way I should proceed. I should not put the formula and first find out this one. Then for this I have to find out this. It will be going expanding like this. It's not practical. It's not practical. Then how I should do this one? So first I should find smaller values. Then I can get the larger value. And one more important thing you observe here. See, I have.
First you need to find. We need to find smaller values. And then we can go to bigger. Smaller means delta I comma j जो होगा वो लेसर होगा, मिनिमम होगा, मिनिमम.
3,4 in this formula. I have 3,4 here also. So if I find out 3,4, it is useful at different places, right? Not just at one place. It is useful at different places. 4,4. That's the same thing only, right? So it means how actually we should solve this problem. So for this, we will prepare a table. 4 rows, 4 columns. Now this represents. So this is 1, 2, 3, 4 and
4 rows 4 कॉलम क्यों ले रहे हैं सर? जीरो वाले को सर ने नहीं लिया ना. कल जो मैं पढ़ रहा था जीएफजी में पढ़ रहा था या शायद जीपीटी सान से पूछा तो उन्होंने क्या किया था, जीरो से स्टार्ट की थी ये वाली मैट्रिक्स. तो इसमें सर ने केवल 4 एलिमेंट्स लिए हैं रो और कॉलम में, उसने 5 एलिमेंट्स लिए थे. लेकिन अब मुझे ये नहीं पता ए ऑफ 0,0 क्या होता है उसके हिसाब से, पर ठीक है जो भी था.
1, 2, 3, 4. These are row numbers, let us call them as I, and these are column numbers, let us call them as J. So what I will do is, first I will find out smaller values, that is C of 1, 1, C of 2, 2, C of 3, 3, and C of 4, 4. This I will find out. Means 1, 1, 2, 2, 3, 3, 4, 4. So this will already 0, I know it, right? So already I have shown you this one. So this will be 0, so I filled them with 0 already. Then I will find out the values which difference is 1. Difference is 1 means what? 1, 2, 2, 3, 3, 4. Right? See 1, 2 and 2, 3 and 3, 4. These values I will find out. Then with difference with the 2, difference with the 3 finally. So in this way, I will have filled this diagonal, then this diagonal, then this diagonal, and this diagonal. So in this way, let us find out the cost. So let us start finding the cost from smaller values, not from the larger value. This is okay. And what should be the name of that table? Let us call it as, I am calling it as C, no? Cost. So let us say C. In the previous video, I wrote it as M because this I was taking it as M. So M for matrix multiplication. It's the cost of matrix multiplication. You can use any name. That is not an issue. Now, one more table I will make. What is that table? I'll prepare a table first. So this is again 4 rows, 4 columns. 4 rows, 4 columns. I will prepare. This is 1, 2, 3, 4, and 1, 2, 3, 4. What is this for? See, out of these 3, I'll be taking the minimum one, and that cost I'll be writing there. Yes, you remember this? Out of these 2, I'll be taking the minimum one, and I will be writing the cost of 2, 4. Here, 2, 4. I'll be filling it. So I will find out minimum of these 2. So what is the difference between these 2? K value is different. K value. So K value is 2 and K value is 3. So I need to know for which K value I got this minimum answer. K can be 1, K can be 2, K can be 3. So which K has given me a minimum answer? So this table, let us call it as a K table. K. And in the previous video I was calling it as S table. So in the textbooks you will find S as a name, so I have taken S only. But now here I am using variable K, so let us call it as K table. K values will be there. Now I will take an example problem and I will solve it. Let us see how we can solve it by first solving smaller problems, then with the larger problem. So in this table already we know is 1, 1, 2, 2, 3, 3, right? And 4, 4. Now let us fill up the rest of the values. So I will take some dimensions for the 4 matrices and I will solve it. So I have taken the dimensions. 4 matrices are there. This is a dimension D0 and this is
एग्जाम्पल ले लेते हैं भाई. एग्जाम्पल ले लेते हैं क्या सर? A1, A2, A3, A4. ठीक है. और डायमेंशन ले लेते हैं. ये 3, 2 ले लेते हैं. ये 2, 4 ले लेते हैं. ये 4, 2 ले लेते हैं. ये 4, 2, 5 ले लेते हैं. ठीक है सर. ये D0 हो जाएगा, ये D1 हो जाएगा, ये भी D1 हो जाएगा, ये D2 हो जाएगा, ये भी D2 हो जाएगा, ये D3 हो जाएगा, ये भी D3 हो जाएगा, ये D4 हो जाएगा. ठीक है. हाँ ठीक है. तो हम लोग बनाते हैं. सबसे पहले तो इसमें 0, 0, 0 आ जाएगा क्योंकि सेम मल्टीपल मतलब लाइक एक ही C of 1, 1, 1 यानी कि एक की एक से ही मल्टीप्लाई कर रहे हो तो इस टाइप का. ठीक है. यानी 1 to 1 ही मल्टीप्लाई कर रहे हो तो 1 to 1 यानी कि मैट्रिक्स 1 की 1 से ही 1, 2, 3 अगर लिखा होता तो वहाँ पे हो जाता 1 की 2 से 2 की 3 से, मतलब 1 की 2 से फिर जो आएगा उसकी 3 से ऐसा.
We will use this formula, but we will not directly put 1, 4 here. We will put smaller values. So in which way? We will start with differences. That is difference 0, difference 1, and difference 2. Difference 0 already I have filled there. So it is just like C of 1, 1. If I want C of 1, 1. So formula says minimum of, right? K takes the values greater than or equal to 1, but less than 1. So greater than or equal to 1 I can take. But less than 1 how I can take? So I cannot take any K value. So the result of a C of 1, 1 is 0. That's why already it is 0. Similarly for 2, 2, 3, 3, 4, 4 also it is 0. Now we will find out difference 1. So here I will write down C of 1, 2. So let us find out C of 1, 2. This one I am finding. So it's minimum of, let us put it in the formula. Formula says that K can take the values starting from 1, but it should be less than 2. So yes, K can take only one value, that is 1. So let us put it. If I make K as 1, then what it will be? C of 1, K is what? 1. K I am taking it as 1. So 1, C of 1, 1 plus C of K plus 1.
K plus 1, 2.
So 2. Then J. J
2.
is what? 2. This is I, this is J. Remember this. So 2, 2 plus D of I minus 1. K is 1. So D0 into DK, that is D1, into DJ, that is D2. With only one K value possible. So this is only the value, so that itself is minimum. So find out what are D0, D1, D2. So D0 is how much? 3, right? And D1 is how much? D1 is a 2. And D2 is how much? D2 is 4. Then what about C00? Already we have it in the table. That is the benefit we will get now if you start from smaller values for solving such formulas. This is 0 plus this one. How much it is? 2, 3, 6, 6, 4 is 24. So the result of 1, 2 is 24. So I'll write here 24. First value I got. And for which value of K I got that 24? 1, 2 here. K value was 1. So put it as 1. So k of 1 comma 2 is 1. That k value has given us the result. Now let us find out c of 2 comma 3, cost of 2 comma 3. So here I write cost of 2, 3, I is 2 and j is 3. So this is minimum of k can take the values starting from 2 but should be less than 3. So only one value that k can take, that is 2. So c of I comma k, k is what? Only possible value is 2. I comma k plus c of k plus 1 to j, j is 3, right? Then plus dimension of k minus 1, that is d1 into k, then j. C22, we already have it in the table, 0. 3, 3 also 0, plus d1, d2, d3, d1, d2, d3, 2, 4, 2. So 2, 4, 2. So how much this is? 0 plus 0, 2 4 is 8, and 8 into 2, 16. So this value is 16. So I will write on the value 16 here. This is 16. And for which value of a k we got that as 16? For k value as a 2. So 2 comma 3 is 2. Right? Now, next value, c of, next is 3 comma 4. Okay? So I will not explain, simply I will write down, okay, to save your time and my time. So here already I have written it, so only your time is saved because I have written this one. So c of 3, 4, 3, 4. So k takes values from 3 to 4, so only one k value is possible, that is 3. So I have taken k value as 3, so these are the costs plus the dimension. So cost is 0, and this is 4 into 2 into 5, so that is 4 into 2 into 5. So 5 4 is 20, and 20 into 2, that is 40. 40 is the answer. So the cost of 3, 4 is how much? 40. Cost of 3 comma 4 is 40.
40.
For which value of k we got this? K value as a 3. So this is 3 comma 4 is 3. Which k value has given? So one diagonal is over. Now next diagonal, these two values with a difference of 2. So I will remove this and I will find out the values for those two. So the first one is 1 comma 3. So cost of 1 comma 3. Cost of 1 comma 3. Formula says that minimum k takes the values greater than or equal to 1 and less than 3.
Less than 3.
Right. So what are the possible values k can take? K can be 1.
1.
And
K can be 2.
K cannot be 3 because it should be less than 3. So let us try both these. K has 1. See, I is 1 and j is 3. Remember this. 1 comma 3, you remember this. So 1 comma 1. C of 2 to 3. D0 into D1 into D3. K value is 1 here. You put this in the formula, you get this one. Then here, C of 1, 2, C of 3, 3, plus D0 into D2 into D3. These are the two. So what are the values? This is 0, 1, 1 is 0, 2, 3, see 1, 1 is 0, 2, 3 is 16, 16, plus this has to be added. Dimensions, 0, 1, 3, 0 is a 3, 1 is a 2, 3 is a 2. So how much this is? 3, 2, 6, 6, 2 is 12, 12 plus 16 is 28. So this is 28. So here I will write down 28 when k is 1. What about this? C12. C12 is 24. This is 24. C33 is 0 plus D0, D2, D3. D0, 3, 4 and 2. So 3 into 4 into 2. 3, 4 is 12, 12 into 2, 24, 24 plus 24, this is 48. So which one is minimum? This one is minimum. So what is the value of k? K is 1 and it is 28. So C of 1, 3 is 28. And for which value of a k we got this? 1. K value is 1. That's it. Now the next one, this one, right? This is 2 to 4. C of 2 to 4. I will write down this and explain you. So here C is of 2 to 3. So what is this? Let us first put dimensions. I will write afterwards. First let us fill up this. 3 to 2 here. I know much of 2. D1, D2. What about this? So 1 comma 4. Less than 4. So I have 2. This is 3, 1, 3, 2 is 3 to 6. In between D3 is there. That is 2. This is, so this is 100, 124. The 30 plus minimum. So this time we have that we now parenthesize these 4 matter to follow this. See, this is the final answer. This is the final answer. Remember this. This is 1 comma 4. So when you have 1 to 4, then where the parenthesization should be done? At a 3. At a 3 you have to do. From 1 to 4 you have to do parenthesization at a 3. So at a 3 you put the parenthesis. First step. I'll write them once again so that you can separately see them. Okay. This is A4. So I have written them once again. So this is the first parenthesis I have put in. So I have taken once again. Now this is only one matrix. When one matrix is there, you don't have to worry. What about these 3? 1 comma 3. 1 comma 3 is how much? 1. So parenthesization should be done at 1. So this has to be separated. Then definitely what is left over now? This is 2 to 3 is left over because we'll be multiplying 2 matrices. This is separated. Like how I have separated this. Okay, I should have put parentheses here also. See, when it was 1 to 4, again I am showing you. So it was said that k is a 3. It said that k is 3. So at a 3 I have separated and that side separated. Now within this bracket 1 to 3, 1 to 3 said that 1 to 3 is 1. So put a bracket at 1. Then 2 to 3 goes on that side. Now this is complete. This is total parenthesization. So this means that A1 should be multiplied with the result of A2, A3 and their result should be multiplied with A4. So I'll show you diagrammatically. So as per the brackets, if you see A2, A3, all. is that put a bracket like this, okay? So don't have to do it. One, and we can say this is not always taking n value. So if you want to,
तो गाइज आज के लिए बस इतना ही। मुझे लगी है नींद, मुझे पता नहीं आजकल मुझे बहुत जल्दी नींद आ जा रही है। मैं देखता हूँ, ट्राई करता हूँ कल सुबह जल्दी उठ के जिम जाने की, और कल मैं दिन में बैठ के ये जितनी भी एल्गोरिदम्स हैं इनका एनिमेशन काइंड ऑफ बनाने की कोशिश करूँगा। मैनिम नाम से एक लाइब्रेरी है, वो मैं सीख रहा हूँ, बट मुझे उतना अभी आता नहीं है मैनिम कि मैं ये सब इस लेवल की बना पाऊँ। कर्सर वगैरह यूज़ करके देखूंगा, अगर मैं इसका एनिमेशन बना सकता हूँ तो इट वुड बी लाइक ग्रेट फॉर मी टू लर्न विदाउट वेस्टिंग एनी लाइक टाइम, कि तुमको क्या एक एक लाइन पढ़नी नहीं पड़ेगी, तुम जस्ट एनिमेशन देख सकते हो और उससे फिगर आउट कर सकते हो कि तुम्हारी एल्गोरिदम कैसे काम कर रही है। तो यार आज के लिए बस इतना ही। आज की इस वीडियो में 50 मिनट की लाइव हुई है बहुत दिन के बाद में, और ये वीडियो थी 52 मिनट्स के आसपास की, और हम लोग 50 मिनट लाइव आ चुके हैं। तो ठीक है, मिलते हैं अब नेक्स्ट वीडियो में नेक्स्ट टॉपिक के साथ। तब तक के लिए बाय बाय, टाटा, सी यू, हैव अ गुड डे। एंड जिन्होंने सब्सक्राइब नहीं किया है सब्सक्राइब कर लेना चैनल को, और लाइव आते रहते हैं हम लोग, लाइव बैठ के हम लोग पढ़ेंगे। तो और भी चीज़ें मैं करने की सोच रहा हूँ पैरेलली, तो विदाउट, ठीक है।